Okay, so we're going to look at first video for deformation of solids. Okay, so what does it actually mean? Well, you can check the dictionary, we can discuss it in class, but deformation is essentially about changing shape. You've done it over the years. You've mainly done something called Hooke's Law, which is the same sort of thing. So, let's have a look. Tensile forces. So what are these forces? Well, these forces, these forces work in such a way that they are going to change the length of a object. Okay, so two forces that are in opposite directions. If you look at the diagram, okay, they're in opposite directions, but they're on the same line. You can see if there was a line going through there, they would be on the same line, acting upon a solid so that it may change the length and it's in the same direction as the forces. However, the other way, compressive forces, well, you could use the same definition, but in this case, it's exactly the same. But this one is to shorten, whereas if you're looking at tensile ones, is going to change the length and extend it. Now, if we're looking at this diagram here, this is a crane, so similar to this one. Here's that frame we've got, okay, and there's a mass hanging off it. If you can think about this side here, this side is going to try and compress, and same with this one, okay. It's like an arm, okay. The muscles on this side here will contract, okay. So these muscles will contract, and these ones are going to extend. Okay, so A and B are tensile and C and D are compressive. So here's a Hooke's Law experiment. You've done it before. Essentially this is just a tensile force experiment. Now the thing about Hooke's Law is you're going to get a graph of force versus extension for your data. We know that that's not the normal way of doing things, okay. You normally would do X versus F, okay, because of the F being the independent variable and X being the dependent variable. This is how you probably will see it in the exam. However, this is the way you use to find K, okay. This one, if you find the gradient of that, you'll find 1 over K. So it's very important for the exam, is that when you find the gradient of F over X, you find K, but X over F is going to be the inverse of that. Now, this thing is a constant, provided you don't change the length of the object, don't change the area of your object, or change the material of the object. So, come. Okay, so what is the spring constant symbol? Well, the spring constant symbol is K, okay, generally. What's the units? Okay, well, K is going to be equal to your y-axis divided by x-axis, so it's going to be newtons divided by meters, so newtons per meter. What does it mean? Okay, it means essentially how much force it takes to extend a meter. Okay, so force per unit meter, okay, of extension. So if we're looking at these examples here, let's say we have this single mass, let's call it mass of 1, and it's going to extend it 1. Okay. If we have a double spring, same type of spring, just double of them, we're now going to get extension that is going to be a half, and the same mass, okay, in other words, the same force. And so this one is now going to be twice as hard to extend. So the spring constant K is actually going to be doubled. There's twice the force to get the same extension. This one here, we've got a force that is consistent, okay, on both these springs. So both of these springs are going to extend a distance x. So that's 2x in total, okay, for the same force. So it's actually twice as easy. So we're actually going to have half the spring constant. On this one here, we've got the force F on that one, force F on that one, but that's going to split into 2. So there'll be half F on that one and half F on that one. Okay, so this one's going to extend up here by half x, and this is going to extend by x. So in total, we've extended by 1.5x. So if you're going to do this, it's going to be 3 over 2x. Is going to be your extension. So look at what we did before. Is just going to go essentially on the bottom line. Okay, so it's going to be 2/3 of k. Check that one. Am I right? Analyzing the graph. Okay, so we've got this thing here. I want to know if the gradient is 25, then using the equation, we can get that formula. Okay, so for any x, we can find any f. Any f, we can find any x. What's the limit of proportionality? Okay, it's when it starts being no longer a straight line. The spring was made twice as stiff. What would the graph and equation look like? Okay, so twice as hard to extend at the same distance. So this would then go up to 50. Okay, gradient must then be steeper. Okay, twice as steep. Hooke's law, find it and state it. Okay, just look in the dictionary. Okay, essentially it states that the force is proportional to extension provided that that limit of proportionality has not been passed.